In this video, we are going to focus on revision exercise 5, indices, logarithms and sequences. You will find this on page 223 in the Namibian Ordinary Level Mathematics textbook, y equals mx plus c to success. If you look at number 1, you will see it's all indices. Now, I think the best will be if we just go back to the chapter and just quickly revise all the rules of indices. You will find that on page, but if you start in the chapter, you're going to find it on page 181. Can I just make it, I'm first going to move it up. Do you see there? And very important, this is also coming, some of them from grade 8 and 9, but is that you know that rules. So remember, if the bases are the same, look here, if the bases are the same, what do I do with the exponents or the indices? I just add it up. And if it's multiplication, and if it's division, I subtract it. And if I have a base and I almost have like a double index, then I multiply it. And if there's two bases, then this index, and I'm even going to make it bigger still, then this index is going to be for this one as well as for that one. The same, if you have division, then this index is for this one as well as for this one. And you can just go through these examples just to understand. So I add, I subtract, I multiply, it's going for the x as well as the y, it's going for the x on top as well as the y. Okay, let's go through the next rule. I can just say the rules to you. This is the multiplication, this is division, and this is the power law. And then it's just a few practice, and then I want to show you also, just remind you, before you start doing that, if you look, so anything to the power of 0, do you see there? Anything to the power of 0 is equal to 1. Okay, and if, and I'm even going to make it still bigger, and if you have a negative index, there you have a negative index, and you want to make it positive, then don't forget it's over 1. So then I just bring it down, and then it's positive. But if you have, say for example, can I give you this? Then, and it's negative and it's in the denominator, then you just bring it up, and it's going to be 5 to the power of 2. Okay, so to change the sign, just take it from the top to the bottom, or from the bottom to the top. Okay, that's also a rule. Let me just see the next rule. This last rule I want to show you. Okay, this is fractional. So what do I do to get that fraction, that index, to a root? Just remember it like this. I'm going to show you there. The one on top is on the outside, and the one at the bottom is on the inside. And I think it's better if you see it here. The top, okay, the one on the top, I'm saying it incorrect. The one on the top is on the inside. Do you see there? And the one at the bottom is on the outside. How I remember it, can I just show you? I always remember that a square root is a half. And then I think, okay, if there stands nothing, that's a 1, and there's a 2. So the 1 is on top, the inside, and the one on the outside is at the bottom. And this, can you see? There's the 1 and the, so that 1 is on the outside. Okay, I'm saying it now correct. And the same here, if it's m over n, just that one at the denominator is on the outside, and the one at the numerator is on the inside. Okay, and that's the rules. Now we can go back to the exercise. So always just quickly reflect your rules. I just want to get that line away. Okay, it's better. So if I look at this one, and I'm starting here at number 1a, I'm just going to say this is just multiplication. Can you see that? So the bases are the same, and it's just, I'm going to add it. 3 plus 4, and I can even write it, it's not necessary, and it's going to be p to the power of 7. Okay, then I start with the next one, number b, and now it's 15, and it's k to the power of 8, divide 3, k to the power of 2. Now, sometimes it's better if you write it like this. Write that one on top, numerator, that one at the bottom. Then it's sometimes easier to see. So now I say 3 can go in 1, 3 can go in 5. So I'm going to have my 5, and there is my k, and it's, now I subtract 8 minus 2, and that's 6. Just remember, I always tell students, if it's like this, say for example, it's not like this, it's just showing you an example. Say for example, you were having, let's just get my pen correct, you were having A2 and A7. Then I always tell them, where is the big amount? It's at the bottom. So there's 7 at the bottom and 2 on the top. So 2 of the 7 at the bottom cancel, but the 5 is left at the bottom. Do you see it there? But I always tell them, where's the big amount? It's at the bottom. So then write the A at the bottom. There's nothing on top, I just put a 1. And then do the calculation at the bottom. So say 7 minus 2, and that's 5. But in this case, the big amount was on top, and that's why I did the calculation on top. And 8 minus 2, that would have been 6. Okay. And then the next one, number C. P4 over 16. Now, in this case, you can, I'm actually going to do it a little bit different, but you can even use a calculator. They don't say without a calculator, so it's fine. But I want to show you actually without a calculator. Now, if I do it without a calculator, I write this in prime factors. Can you still remember prime factors? It's that where it's in the beginning of the textbook. So it takes 16, and I take the prime numbers, and I start, and I say 2 can go in 8, 2 can go in 4, 2 can go in 2, 2 can go in 1. So it's 2 to the power of 4. Okay, so now, and I can make that 3/4, but again, you can use your calculator. So it's P4 over 2 to the power of 4, and if you make that vulgar fraction, it's 3/4, because then it's easy to see. I'm saying P, and it's just that 4 over 1 times 3/4 over 2, 4 times 3/4. And that is going to give me an answer of P, and the 4's cancel out, so P to the power of 3, and 2, the 4's cancel out, 2 to the power of 3, can you see that? And my final answer is just going to be, just move it up a little bit. It's going to be P to the power of 3, and 2 times 2 times 2 is just going to be 8. That's going to be my final answer. Okay, let's move on. Okay, that was number C. I'm just going to make space. So just know your laws, know your rules, and it's not a lot. And then you can do it from there. And then I do number 1D. Okay, now be careful. Just look at your signs. Be careful for this one. There's not a multiply. It's just like terms. It's also a Q, and it's a quarter, and it's times Q and a quarter. And okay, this is like terms, so it's 1 and 1. So it's 2, Q2, and this, it's Q. A quarter, it's multiply. So I add, so it's a quarter plus a quarter, and that's a half. Or it's 2 over 4, but which is a half. Okay, now I'm just going to rewrite it as I want to simplify it. Then don't forget, it's still the bases are the same. And what do I do? If it's division, I subtract. So this is going to give me then 2q2 minus a half. And that's going to be 2q, and it's going to be 1 and a half. Okay, and I can leave it like that, or I can go back to the fractions. So then I'm going to say, let's just go further. I'm going to say 2. I'm first going to make it improper, so it's 3 over 2, just to practice that fractions also. And now remember, this one, it's a root, and this one is on the outside, so it's actually a 2, but you don't have to write it, and that's the 3, and that can also be your final answer. So very important, just take it step by step. Don't try to do everything in one step. You do the addition, you do the multiplication, and then you get to the subtraction, and then you can even take it to a root. Okay, that's how you do that, indices. If you look at this one, and now this one, and I want you to see, this one was expressions. So I just did the rules. If you look there, then this one is an exponential equation. Okay? I just want to get the... So again, let's just go to the chapter. So, and I always like telling students, before you start doing the revision exercise, and I was writing it down, it's on page 186. So let's just find 186. What is this one? Okay, it seems to me a little bit previous. Okay, it's exponential equations. Now, what I'm usually telling students, especially before an examination, don't focus on just one exercise or one sum. You have to know everything now by this stage, but it's then if you can still struggle a little bit with a few intensive type of things, but it's more important that you just go through the basics. So I usually write my textbooks like this. I do one of the sums in a block. So before the examination, I say, just take a piece of paper and cover that. And if you have time, then just quickly do that sum and check if you are correct. And then you just go to the next block. You do that sums and you just check if you are correct. So you just do the blocks just to refresh yourself on the basics. And if you think you know the basics, you can just do like in the previous number 1, just refresh yourself with the rules, and that's enough. So don't try to spend all your time in just one chapter. It's more important that there's now 12 chapters, that you just go through the basics of the 12 chapters. Okay, but for now, I just want to show you. If it's an equation now, what I'm trying to do, and this is what I'm going to show you, I'm trying to make the bases the same. Because if the bases are the same, and I have one term equals one term, I can go and I can put the indices equal to each other. Do you see? X is equal. If it's not the same, I write it as prime factors, and then I put... You see, the bases must be the same, and then I put the index equal to each other. Okay, and I'm just going, and I still want to show you a few things before I go back. So if you look at this one, and again, I don't like it if that line is start to become part of the shell. Okay, it's not one to see. No, okay, just leave it there. Okay, so if it's 1, now remember the rule. 1 can be any base. So if you see it's 5, then make it 5 to the power of 0. If you see it's 7, then make it 7 to the power of 0. But in this case, it's 5, so make it 5 to the power of 0. And then the bases are the same, so you're going to say x is equal to 0. Okay. Here, again, prime factors, and bring it to one level. Do you see? So I'm bringing it up, and if I bring it up, what must I do? I must change that positive into a negative. And as soon as the bases are the same, then I'm just going to say this index is equal to that, and then I just solve the equation. And if you see a decimal, just make it a vulgar fraction first. You can first make it, there's 3 decimals, so 1 to 5 over 1,000, then use your calculator. Say 125 ABC 1000, and that will give you 1 over 8. So first simplify it, and then write prime factors. So it's 2 to the power of 3. Then bring it up. Now it's on the same level, and then you can say x is equal to -3. So if you don't have a lot of time, and it will take too much time just to do all the sums, then at least just check them, that you just say, okay, no, I can do that. That's not so difficult. Okay. I'm just going to show you this one. I think then we're done. If you see 2, then you must make it just one base there. So if you do that, I'm just going to do it like this. First it's 5y, and then I multiply, do you see? And then I do the rule. I add the exponents. And now I have 1 base equals 1 base. And then I say that this is equal to this. And then I just simplify. Okay. This is a bit more complicated, but still you use the basic rules. And I just run quickly through this last one. And then I go back. So if you look at this one, then this one, okay, here, this is a bit more challenging, because now there's not a multiply or a divide, this is subtraction. Now, this is what I do then, is I first break it up, I reverse back. I say this is 5 to the power x times 5 to the power of 2. There I break it up. This is 5 to the power x times 5 to the power -1. And then I take, then look here, it's 2 terms. I take 5 to the power x out as a common factor. And then I have that. And then I simplify. That's 25, 1 over 5. And I first simplify. And I first divide. And then I'm trying to get the bases the same by going to prime factors, and then I equate. So this was a negative, then it's a bit more, then we call that splitting. It's not so often that they ask it, but if they ask it, you can also, and there's another one in that. Okay, and I think that was the last one. Yes, I just want to see, okay, can I just show you this one? Now, in the previous ones, and I want to go back, I just want to go back. In the previous ones, the x was in the exponent, in the index. Do you see that? You can then also do it with logs, which I will show you later now. But I did it now without logs. So to logs bring a x in the index, it brings it down to the base. But I will show you in the next examples that I will use logs. But if you look now, the x is not in the index, it's still in the base, but the index is a fraction. And then all that we do is we want to try, we're just trying to get it x to the power 1. So to get that to 1, and I'm going to make it a little bit bigger, that you see that. We basically just go and multiply by the reciprocal. So the reciprocal will be 3 over 2. And remember, what you do on one side of an equation, you do on the other. So you take it prime factors and you multiply both sides. And then this becomes that perfect 1. This cancel out, and this is your answer. If it's a negative, you want it positive. You just multiply with negative and then the reciprocal. And the same, negative and then the reciprocal. Okay, and that. Okay, yeah, this is very important. Your x must be 1. So you first must make it 1. So I first divide by 4, so to get it 1. And then I take my prime factors, and then I multiply with 3 over 2. And I multiply with 3 over 2. And then I'm getting my answer. And I think that was the final. And I think here it's just, this is a bit challenging. And I don't think they will go to this level. But it's especially important for the AS level. People who will do AS. But in this case, okay, it's basically, it's factorizing. It's a quadratic trinomial. So if you see that this, if you say 1/3 plus 1/3, and you get its double, 2 over 3, then you know it's a quadratic trinomial. And then you factorize it, it's in group B, do you see? And then you just get your factors, and now you're just going and you just put that x to the power 1. So you can make it k, that's going to work. Otherwise, you just go directly. I can just show you here. This was just 3 and 1, and it was 7 and 3. This is group B, as I always call it. So this is 9 minus 7, and that's 2. And you just go directly and you say a third. It's always that middle that you put here. And the signs are different, and the biggest overcross get the negative, positive. Okay, and I end up with that 2 brackets. So I have 3 x a third minus 7, and I have x a third plus 3, and that's equal 0. Then I put this bracket equals 0, this bracket equals 0. That's what I did there, and then I just do as the previous. I want to get it x to the power 1, so I multiply the reciprocal, and I get this, and I multiply, and I get this. So this is, all of them are quadratic trinomials, and you can always see that if you multiply this by 2, you will get that one, or a third plus a third, you will get a fifth plus a fifth, you will get that one. Okay, and then I think we will come to the next, which we will do. So let's first go back. I just refresh. So this is what I will do before, when I'm preparing for an examination. I will just quickly run through the blocks, and then you can tackle the revision exercise. Okay, so now, and it's actually just one sum, and I must now try to fit it in. Okay, so let's just get and see. This is an equation, do you see? And the exponent is on top, so I can do it with logs. But now maybe as soon as I do logs, I will come back to this one. But for now, I'm just going to do it without logs, because it works without logs. And then I'm just going to say 3, 2, okay? And it's going to be 2 to the power of k. Okay, and now 32, and you know, I always said the golden rule in indices is break it up into prime factors. So you say 2, and that's going 16, and 2 is the prime numbers, and it's 8, and it's 2, and it's 4, and it's 2, and it's 2, and it's 2, and it's 1. 1, 2, 3, 4, 5. So it's 2 to the power of 5. So it's 2 to the power of 5. Okay, now don't forget. Okay, now let's first leave it like that. I don't want in this last to leave out steps. Now, if there stands nothing, there stands a 2. So it's 2, 5 over 2 equals 2 to the power of k. And then I multiply. Can you remember? Okay, let me just show you. Now, let's just go back. The bases are the same, and if the bases, and I have one base equals one base, I just put the index, the indices equal to each other. So I say 5 over 2 is equal to k. So therefore, you can either say k is 5 over 2, or k is 2.5, and that's the final answer. I will show you also how to do it with logs, but as soon as I revised logs. Okay, so I think it's now time to revise logs. And again, just know your laws, know your rules. Now let's go back to logs. Now on this level, they will just ask with a base of 10. On AS level, we will take it a bit further. But for now, just know the base of 10. Okay, so documents, and I want to go to logs, and it seems to me I was writing there, it's on page 192. So let's see what page is this. You can again go to that index. Just to spare a little bit time in the videos, I'm not going to the index. Okay, this is all logs. I just run through the rules. Okay, I want to show you one thing, and this is actually more important. Now you must just know the rules more or less, and with the rules you can do the calculations. Okay, but can I just say, and I just want to explain this maybe a little bit to you. It's actually, logs is almost like, it's okay. Can I start by saying, if you have a bracket and you multiply it out, you expand it, you get 2 x plus 6. So in this case, I did multiply. If I want to reverse back, I call it in maths, I factorize. Okay, that's what we did in chapter 3. Now, if you have logs, if you have, say, 10 to the power of 3, I know what's 10 to the power of 3. It's 1,000. Now, it's almost like this is now indices. If I'm giving you this and I'm giving you this and I want you to work out this, I want you to reverse back. I'm taking the logs. Okay, so that is why this is actually the reverse of indices. So I will say 10 to the power of what is 1,000, and then I will just write it like this. But can I show you? So it's very important that you can write from index form to log form. And how do I do that? I keep the base. So I write log and I keep the base. The base is 10. I just move it down. And then basically, and I want to show you, I'm just taking this 2 and I just swap it. So I say log 1,000. Just go back. And that will be equal to 3. Did you see? I just swapped that 2. So this is for me important, especially if you go to AS level, that you know how to swap it. And if you press this now on the calculator, because your calculator is programmed to do a base of 10, you will get 3. So if you press on your calculator log 1,000, you will get 3. Okay, and maybe this is what I do in the first step. I'm just showing you here to go from index form to log form, or to go from log form to index form. Okay, so if I look at this one, I'm just going to make quickly space. So if I say 3 to the power of 3 is 27, and I want to put it in logs. Now, this you will not be able to calculate, so it's just conversion. So it will be log, you keep the 3, okay, and you take that 2 and you swap it. So then you will write the 27, and it's on the same line, and it's equal to 3. Okay, so that's how I go from index to log. And then the next one, I think it will just be the next from log to index. So if I'm having one like this, I have log, and it's the same principle. Now the base is x, so keep the base, and then take this 2 and swap it back. So it's going to be x to the power of 3, and that will be equal to 8. Okay, x to the power of 3 is equal to 8. And this one, you keep the 7 and you swap this 2. So 7 to the power of 1 is equal to 7. And that's how you do it. Okay, not so difficult. Very important that if you go on AS level, that you will go back to this kind and you will know what log. So that you don't, because this is very important, maybe the last step, but it's not so important for calculations now in this examination. But this value of a, where is the value? The base must be bigger than 0, do you see? And a cannot be 1, so the base cannot be 1. And y must be bigger than 0. So if you press, go and take your calculator and press log -3. Go and press that on, make that and see what your calculator is saying. It's an error, because that, the value, the number there must be bigger than 0, and that's why I just explained that to you. Okay, and then I just very quickly run through the rules. So if I'm going to the rules, and I'm just going to show you here, I just want to see, it's just how to press it on the calculator. So it's very easy. You just press log 3 equals log 100. The calculator is programmed for 10. So that, but I want to more focus on just the laws. And if I, first the product law, it's just 3. And it helps you just to make it one term or to make it more. So the product rule is if there's a positive. Now I want you to focus here. With the positive, there stands 2 log words. But then it's going to multiply, it's coming from exponents. So the reason why is, can you remember if you were saying x2 times x3, then it was x, and what did you do with, you were adding it up. And that's the reason why this rule is like this. So multiply and addition, but with the addition there stands 2 log words, but with the multiplication there only stands 1. So it's not equal to log x multiply log y. Only 1 log xy. But with the addition, it is that is equal, you can do the reverse, to log x plus log y. So with the addition 2 words, and with the multiplication 1. That's the first rule. The next one, and that's just applying the rules. I just want to go through the rules. There I showed you, and then I come to the next one. Let's just see the product law. Maybe I skipped one. No, that was nice. I just want to see if the subtraction. I want to come to the subtraction one. And again, you just flip quickly through the textbook. Okay, but here, can you see? Now it's subtraction, but please people, it's coming from indices. So if you have indices and you have a 6 and you have a 2, what did you do? When it was division, I said x6 minus 2. So division goes with subtraction, and that's why the law is going to say log x minus log y, and again with the division it's only 1 word, and it's just x over y, but with the subtraction there's 2 words. Okay, are you with me what I'm meaning with the words? So it's not equal, and I think I'm showing you now, to that log x divide log y. No. So with the subtraction 2 words, but with the division just 1 word. That's the next rule. And then the next one, quotient, and then, okay, there I showed it to you. Okay, so it's incorrect, that one. There's the rule. And then the power law. Oh, this is a nice one. Usually you like, and this is one you use a lot. The power law is just coming from this. It's almost like, okay, so yes, it's coming from the multiply. Okay, so let's just go through that one. So basically, can I just show you? The power one is just if it's on top. Okay, do you see? Then I just bring it to the front on the ground. So the n, I'm going to make it bigger that you see that. So the n was standing there on top, and all that I do is I'm bringing it to the front. Did you see there? Okay, and that's how, and it's coming from there. Did you see? I'm showing you. It's related to that law, and that's the one. So anything you have. So if you have, can I just put it in a number? If you have 5 to the power of 2, then that will be, bring the 2 in front to the ground, and that will be equal to each other. Okay. And that's the laws. And I'm not going to, maybe I will just go a little bit further. That's the laws, because I want to show you just the calculation using the laws. Okay, using the laws. So I just want to go a bit further and see if I expand and separate. Okay, I'll come now to equations. I think I first want to do the basics. Then I'll rather come back. Okay. So in this case, I'm just going to use that. And if you're going to forget, just going to go and write it down for yourself. So in this case, remember what I said? It was on page 192. So I'm just going to write it down, and it's just going to help me quickly. So I'm just going to write down the laws here for me. So if and what a nice thing is, if you go to the summary, I'm telling you all the laws there. So in the summary, and that the summary is on page 224. So it's going to be log, and because it's all 10, I'm just going to write it like this: log y equals log xy, and then log x minus log y equals log, let's just get that, x over y, and then this is the first one, the second one. So it's the product, the quotient, and then the power one is log, and this is now just base of 10, so it's easier if I write it like this, xn, and that is equal to n log x. There's your free rules. And so go through the summary and just memorize that rules, all the rules. And I actually could have just worked with the summary. All the rules stands on page 224. Okay, so let's just start. So if I'm going to look at this one, I'm saying write as a single. So it's just to test. So it's an expression. Do you see there's no equal sign? I will now make it an equal sign and use that. But for now, I'm just saying, I'm just going to, and they can ask me, so they write it as a single, or I can do the reverse also. I give you a single and you write it separate. But it's just like this, not very difficult. It's just testing if you know the laws. Okay, so in this case, I'm just basically going to go and I'm just always first do this one. This will always be the one that you do first. So if I'm going to do that one, I'm just going to jump up. So it's like I give you this and you work back there. Jump up. Okay, and now I always have this saying, all the ones that subtracted must be at the bottom, and the one that's added must be on top. Okay, because the reason why is that you can write it also like this. I'm just showing you. I'm going to leave that one, this a bit big. Do you see, if you take out the negative, it will be a positive, and 3 times 3, that will be 9. So it's going to be log, and then 62 over, and then that's 4 times 9. So the ones that will be multiply, but because of the subtraction, it will be at the bottom. But you can just go, all the ones that subtracted is at the bottom. All the ones that's add is on the top, and that's simplified. You can go a little bit further. No, it seems to me I didn't clean nice the previous time. You can go a little bit further. And okay, so 60 times 60 is 3,600. And this is 36. And if you simplify this, this is log 100. And interesting, log 100. What is log 100? It's just 2. What is log? Okay, you can test it on your calculator. So log 100 is 2. Log 1,000 is 3. And log 10 is going to be 1. Okay, and that's how you do it. And now I'm going to use it. So let's just go. I'm just going to go again, and you will find that. I'm just going to tell you where to find that. You will find that on page 201. So let's just go back. 201. Okay, let's just see. I think it's best that I first. Okay, here it is. Okay, let's just start. Okay, so the first one, I'm just quickly refresh your memory. Okay. Now, in this case, I told you can do the previous one. So you can either do it like we did, make the bases the same, or you can put logs on both sides. But equation is like this. If you put log on one side, you put log on the other side. And then you just simplify. First do that rule, bring the x down, do you see? And then divide by it and you get your value of 3. Put logs on both sides, bring it down, and that's basically what you do. Okay, so if you want to bring an x to the base, to the ground, almost like the ground, then you can either do it just by using indices, or you can just put logs on both sides. The next one, I just want to show you here. If you have a number in front, we don't like that. So we first divide by 4, divide, and then we take logs on both sides. Okay, that's just showing you that. And the same, okay, this is very interesting, and I want to show, I'm doing that. If you have, and this is very important, if you have x minus 2, you cannot go and say it's log x minus log 2. I'm not even going to write it down. But if you have x minus 2 log, then that will be equal to x log, okay, must make it a number, 5, minus 2 log 5. So if it's in front, you can do this and you can do this. If the bracket stands in front of the log, but if it stands behind the log, you just leave it like that. Okay, so this is very important. So this one, you cannot go further. This one, you can write it as that. And that's what I did there. Okay, although I divide by log 7, then it was not necessary. And I divide by log 7, and then I just simplified it. Okay, and then the next one, that was exponential. So if you check at this, I want to show you. I want to go back. In this case, there was no log. Do you see? There was no log. So I was putting logs to both sides, but there was no log. It was just an exponential or an indice equation. But in this one, if you look here, you will see, I want to show you here. In this one, there will be logs. So I will take the logs away, but I must first get one term equals 1 log, then I can do the reverse. I take the logs away, and then I use the rules. But I like to do this one. If there's only 1 log, I can, just like the previous example, remember it's 10, I can go from log form to exponential form. Now, can you remember, I write the 10, and I was marking it in yellow in the previous one, and I swap this 2. So I said 10 to the power of 2 is equal to 3x. That's what I did. And then I basically just solve it from there. Okay. The next one. Now this one, I use the rules. There's a plus. So if there's a plus, the rule is the product rule. So then I write, and there's the product law. So I write log, one word, because it's, and then I multiply. Do you see what I multiply? I took this and I multiply it with this. So there I multiply it. Okay, there, do you see? And then it's 1. And then don't forget, then I did the same as this one. I went from log form to exponential form. Okay, can I just show you that one step? You could have also, you were having log, and then you were having x minus 3. Okay, you could have, it was like this. You could have made this a log word. Now, because you just work with a base of 10, you can remember it like this. Now, I'm going to put it here in a block. 1 is equal to log 10 because it's 10. 2 is equal to log 100. And 3 is equal to log 1,000. Okay, and so you can go on. 4, it's equal to log 10,000. Okay, so you could have also do it like this. Say log x minus 3 equals, it's 1, so it's log 10. And now I take the logs away. So it's x minus 3, and that is equal to 10. Okay, and then I basically just multiply out. It's a quadratic equation. I think back of chapter 4, I just factorize it and I get my values. But now, remember that I said log cannot be 0. So if I get my answers, I must test it. I must substitute the 5. I think the 5 will work. Or the 5 is the only solution. But as soon as you substitute the negative, you get negative 3. So press it on the calculator. If you press log negative 5, you cannot get a negative. Then you will say Okay, sorry, that is not applicable or no solution. And the only one is 5, because 5 minus 3 will just give you a log 2. So remember always, with logs, you have to test the answers. It's just like in algebraic fractions, when you are having an x equations. When you were having an x at the bottom, you have to test that you don't divide by 0. So then you also test your answers. Okay, the next one. Okay, let's just go to the next one. Here, I showed you. Can I just very quickly? I don't like to work with division because it makes it difficult. So what I do is I take the negative one over. And then I follow the rule. So if it's plus the product rule, it becomes 3 times x. And then I take logs away. Do you see? And I just solve it. Here also, if it's plus, it's multiply. And then I jump up. And this is equal. And then I just multiply it out. Okay. And that's that. And they will not give you too difficult. So let's go back. Let's go back to our exercise. Okay. Let's do it. Let's keep the rules. You must know that rule. So if I can give you good advice to before you write the examination the next morning or the morning before, just go through the summary pages of the textbook. There you will find all the rules and just make sure that you know all the rules for the examination. Okay, so it's always at the end of the chapter. You will find a nice summary. Okay, let's do number 3. Now, number 3 is finished, luckily. So it's number 4. Okay, now there was 3. That's number 4. Okay, so there's no log. Do you see that? And actually, interesting, you can do it by making the bases the same. But I want to do it with logs, but you can do it on both methods. Both methods will work. Okay, and I think I actually did that method there. I did it with not with logs. I did it with exponents in the teacher's guide. I'm going to see if I can do it with logs, just to help you. So I put logs on both sides. Okay, then I follow this, my rule there. So I bring it in front. Okay, so I'm going to get 3x plus 1, and remember it's in front, and I have log 3 equals 2x minus 4 log 9. Okay, and now I want to see if I can divide that, if this is going to help me, if I'm doing that. Okay, I think it's going to work. Okay, I think I'm going to do it a little bit long because I want to show you this. So I'm going to multiply, so I'm going to say 3x. Remember, if it's in front, I can multiply log 3 plus log 3 equals, I multiply 2x log 9 minus 4 log 9. Now I mark all the ones. This is with an x, this is with an x, this is without an x, without an x. So I'm getting 3x log 3 minus 2x log 9 is equal to, this is negative 4 log 9 minus log 3. Okay, then I'm just going to see what can I do here. Let's just take this up. I think it would have been easier with the other method. Okay, but it's all right. I'm just going to take x out. So I'm going to get 3 log 3. And maybe I'm going to do the other method and show you that it's easier. Minus 2 log 9 is equal to, and this I can actually just work it out on a calculator. I think I'm going to try to just work it out, just don't simplify. Say negative 4 times log 9 minus log 3 equals, no, it's going to be negative 4 point, and now I must not approximate. Okay, and then this one is going to be x, and I have log 3 to the power of 3 minus log 9 to the power of 2, and I have that value. Okay, so negative 4.29409. Oh, this is a stupid method. Okay, now I get something there. I can even, if I divide by this, I can make it a division. I think it's going to be easier. So I'm going to make it log 27 over 81. Do you see? And you're having that negative 4.29. Don't approximate here. And I'm moving up. And then I'm just divide by this log 27 over 81. Log 27 over 81. Okay, I should have made this 9 to the power of negative 4 and just work in one step, but it's fine. So it's going to be negative 4.294091292 divide bracket log bracket 27 divide 81 close the bracket equals, and that is, and the reason why I get 8.9999 is because I did this method, and I shouldn't simplify here. I should make it, and I'll test it now if it will work. So my answer will be 9. Okay, because my calculator is 8.999 and it's just due to that approximation. I just want to test quickly something. If I say log, if it was 9 to the power, okay, I just want to test something. If I was keeping this as log 9 to the power negative 4 over 3. Okay, actually 9 is not so long, over 3. I just want to see if I was saying log bracket 9 to the power negative 4 divide 3 close the bracket equals, yes, and then divide log bracket 27 divide 81 close the bracket, yes, then I would have get 9. So I think if you were not going to this step, and as I said, I would prefer you do the other method, but I'm showing you both. If you were just leaving it like this, and there just then set log 9 to the power negative 4 over 3 divide, and you press everything on the calculator, you will directly get, you will not get 8.999, you will get 9. But if you come to 9, you are correct. But I must show you the other method. This method is too long, and I think on ordinary level, AS level, yes, but on ordinary level, I think it's best to do this method. To do it not for this long ones. You can do it there. And I'll show you now. I'm going to come back to this one. Okay, I want to show you how I do. So let's just keep, because I saw 3 and 9, and I know that, oh, that's going to be nice. Because 3 to the power 2, do you see? And I want to show you that it's easier. So it's 3, and then it's 3x plus 1, and that's 3, and that's going to be 4x minus 8. And now the bases are the same. Can you see how easy it is? So 3x plus 1 is going to be 4x minus 8. And then it's 3x minus 4x is equal to negative 8 minus 1. So it's negative 1x equals negative 9. Divide negative 1, negative 1. Ah, it's so easy. And then, therefore, x will equal to 9. Very easy. So don't do logs if you see that 3 and that's 9. So it's almost like you can see that you can make the bases the same. I want to just, because I have to show you in this one. And I'm thinking of making this in 2 parts and call this part 1 and then do sequences in the next to not make the video so long. Okay. But I'm going to end off this video and I will do sequences in the next video. I'm going to end off this video by showing you I could have used logs here. So number 2, if you say 3, 2 equals 2k. So always if the variable is in the index or in the exponent, you can bring it down by making use of logs. Now I did it in the previous one with exponents, it's good. Or you could have just put logs on both sides. And then you do that law, the third one. And then you just, you just divide log 2 and you just divide log 2. And then you take your calculator and you're just going to say log square root 32 equals divide log 2 equals, and therefore I get 2.5 equals k, so therefore k is equal to 2.5. So you could have do it with in exponents or you could have do it with logs. So we always do it when the unknown is on top, if it's in the exponent or in the index. That's how we call. In the next video, I will look at sequences.